Welcome to Brain Vision.
Okay, so we have the moon. It's being pulled towards Earth by a force of the Earth. It's being pulled towards the sun by a force of the sun. So we know gravitational forces are big G, mass 1 times mass 2 over the radius, basically the distance between them squared, right? So, yeah, we basically just have to find the force from the Earth and the force from the sun. So force from the Earth is going to be G, right? Mass of the Earth, mass of the moon over the radius, Earth-Moon radius squared. While force from the sun is going to be big G, mass from the sun, mass from the moon, radius between them squared. So that gives us, basically, we have this hang on, let me back up here. So if we have our force diagram, we're going to have this force, which is G, M over radius sun squared. We have this force, right, which is similar. So we should expect a resultant force, something like that, right? So we have to add these in quadrature, which basically means the total force, which I'll say F net, is force of the sun squared plus force of the moon squared, square root of that. It's basically the magnitude, the hypotenuse of this triangle right here. So let's plug that in. So that's going to give us, right, force of the sun was G, but it's all squared now. Mass of the sun squared, mass of the moon squared over the radius sun to moon squared, plus big G squared, mass of the Earth squared, mass of the moon squared over Earth-Moon radius squared, square root of that guy. So you can just plug in the values they gave you from here. I'm going to do a little bit of simplifying, though, just because I prefer to. So I'm going to pull out a G, and I'm going to pull out mass of the moon. And then you get, oh, I'm sorry, I actually just realized I made a mistake here. Remember the forces? The force already has square built in. So when I square that, these need to be 4s. I forgot that. Make that a little bigger. Okay, so that needs to be a 4. Okay, so I have that. And then mass of the sun squared over sun-moon radius to the 4th, plus mass of the Earth squared over Earth-Moon radius to the 4th, square root of that guy. And when we plug that in, there's a lot of big values, so I'm rounding a little bit, but it'll be about 4.75 times 10 to the 22nd newtons.